Welcome to Cloudmasters Inc.'s podcast on building fault-tolerant applications on AWS. I'm your host, and today we're joined by our cloud architecture expert to discuss how to create robust, highly available systems using Amazon Web Services. Welcome to the show.
Thanks for having me. I'm excited to dive into this important topic.
Let's start with the basics. Why is fault tolerance so critical for modern applications?
Well, fault tolerance is absolutely essential these days. You see, software has become such an integral part of our daily lives, from mobile apps to banking to traffic lights. Because of this, there's a huge expectation that applications will be available 24/7. Even a few minutes of downtime can cost businesses thousands of dollars. So building fault-tolerant systems that can withstand failures is critical.
That makes sense. And how does AWS help developers build more fault-tolerant applications?
AWS provides an ideal platform for fault-tolerant design. The key is that it allows you to build redundancy and automation into your systems without a huge upfront investment. You can easily spin up backup instances, distribute across multiple data centers, and set up automatic recovery, all while only paying for what you use.
Interesting. So what are some of the key AWS services and features that enable fault tolerance?
There are quite a few, but some of the most important ones are Amazon EC2 for compute, Amazon EBS for storage, elastic IP addresses, auto-scaling, and elastic load balancing. Oh, and we can't forget about using multiple availability zones.
Okay, let's break those down one by one. Can you explain how EC2 helps with fault tolerance?
Sure thing. EC2 is really the foundation for most AWS applications. The key for fault tolerance is creating Amazon Machine Images, or AMIs, of your server configurations. This lets you quickly launch replacement instances if there's a failure. You're not stuck manually rebuilding a crashed server. You just spin up a new one from your AMI template.
That sounds really useful. What about EBS? How does that factor in?
EBS provides persistent block storage that's separate from your EC2 instances. This is crucial because EC2 instance storage is ephemeral. If the instance fails, that data is gone. But with EBS, your data persists even if an instance goes down. You can quickly attach an EBS volume to a replacement instance and be back up and running.
I see. And elastic IP addresses? How do those help with fault tolerance?
Elastic IPs are great for failover scenarios. You can associate an elastic IP with an instance, and if that instance fails, you can quickly remap the IP to a healthy replacement instance. This lets you maintain a consistent address for your application, even as the underlying infrastructure changes.
That makes sense. Now, autoscaling sounds interesting. How does that work?
Autoscaling is a powerful feature that automatically adjusts your EC2 capacity based on conditions you define. For fault tolerance, you can set it to maintain a minimum number of healthy instances. If an instance fails, autoscaling will automatically launch a replacement. You can also use it to scale up capacity during peak times and scale down when demand drops.
Wow, that's really cool. And elastic load balancing? I'm guessing that distributes traffic?
Exactly. Elastic load balancing distributes incoming traffic across multiple EC2 instances. It can detect unhealthy instances and reroute traffic to healthy ones. When combined with autoscaling, it ensures you always have the right number of healthy instances to handle your traffic load.
Got it. Now, you mentioned availability zones. Can you explain what those are and how they contribute to fault tolerance?
Sure thing. Availability zones are distinct locations within an AWS region that are engineered to be isolated from failures in other availability zones. By distributing your application across multiple AZs, you protect against the unlikely event of a whole data center failing. It's a key part of building a highly available, fault-tolerant architecture.
That's really interesting. So how would you typically use multiple AZs in an application design?
A common approach is to create a multi-AZ'd architecture. You'd have redundant instances for each tier of your application. web, application, database, spread across at least 2 AZs. This way, if one AZ has issues, your application can continue running from the other AZ. Elastic load balancing can distribute traffic across the healthy instances in both AZs.
That makes a lot of sense. Now we've talked about EC2 and related services, but what about some of AWS's managed services? Do those help with fault tolerance too?
Absolutely. Services like Amazon S3, Amazon SQS, SimpleDB, and RDS are all designed with fault tolerance in mind. By using these services, you're essentially offloading a lot of the fault tolerance work to AWS. For example, S3 automatically stores your data redundantly across multiple devices and facilities. SQS provides a reliable message queue that can keep your application components decoupled and resilient to failures.
That's really powerful. Can you give us an example of how you might use something like SQS in a fault-tolerant design?
Sure, a common pattern is to use SQS as a buffer between application components. Let's say you have a web app that processes user uploads. Instead of processing uploads directly, your app could put them into an SQS queue. Then you have a fleet of worker instances that pull from the queue and do the processing. If a worker fails, the message stays in the queue and another worker can pick it up. This decoupling makes your system much more resilient to failures.
That's a great example, thanks. Now, we've covered a lot of ground here. If you had to sum up the key principles for building fault-tolerant applications on AWS, what would they be?
Great question. I'd say the key principles are, first, design for failure. Assume components will fail and plan accordingly. Second, use redundancy. Have multiple instances of critical components spread across AZs. Third, automate recovery. Use services like auto-scaling to automatically replace failed instances. Fourth, decouple your components. Use services like SQS to create resilient, loosely coupled architectures. And finally, use AWS managed services where possible. They handle a lot of the fault tolerance complexity for you.
That's a great summary. Before we wrap up, any final thoughts or advice for developers looking to build more fault-tolerant applications on AWS?
I'd say the most important thing is to really embrace the cloud mindset. Don't just lift and shift your on-premises architecture to AWS. Take advantage of the unique capabilities of the cloud to build more resilient systems. And remember, with AWS's pay-as-you-go model, you can experiment and iterate without a huge upfront investment. So don't be afraid to try new approaches and architectures to improve your application's fault tolerance.
That's great advice. Well, we're just about out of time. Thank you so much for sharing your expertise with us today. This has been an incredibly informative discussion about building fault-tolerant applications on AWS.
It's been my pleasure. I hope your listeners found it helpful.
I'm sure they did. And to our listeners, thanks for tuning in to another episode of Cloud Masters Inc.'s podcast. Remember to like, subscribe, and leave us a review if you enjoyed the show. Until next time, keep your heads in the clouds and your applications fault-tolerant.